Imagine the universe as a trampoline net, flexible and vast. Now, picture that net being twisted into a pretzel, with the ability to reverse time. Have you ever truly considered what lies beyond our understanding in the universe? What celestial mysteries are hiding from us? Well, brace yourself for a revelation that might shake everything we thought we knew about the cosmos. This groundbreaking discovery comes from the James Webb Space Telescope, which has shown us something far beyond our expectations. Time itself might not exist in the way we've always understood. Ready to unravel a space-time riddle that could change your entire perception of reality? The James Webb Space Telescope, JWST, is like a more advanced, cooler sibling of the Hubble Space Telescope, launched on Christmas Day 2021. It's been positioned in space to illuminate the universe's most obscure and distant corners, acting like the ultimate time machine. How does it do this? Thanks to its powerful infrared instruments, JWST can peer into the past with extraordinary precision. These instruments allow it to detect faint and distant objects that even Hubble couldn't capture. Galaxies, stars, and nebulae from the early universe. JWST is helping us piece together the universe's massive jigsaw puzzle, one infrared image at a time. The images from JWST are nothing short of stunning. Otherworldly galaxies shimmer across the vastness of space. But for astronomers and cosmologists, there's an unsettling feeling. It's as though they're staring at a Picasso painting in a room full of logical thinkers, and the reaction is the same. This is alarming. Why the concern? The problem lies with a core theory that has stood for centuries. The Big Bang Theory, which suggests that the universe began with a massive explosion about 14 billion years ago and has been expanding ever since. This theory has been the foundation of our understanding of cosmology. However, the new images from JWST seem to challenge the validity of this theory, sending shockwaves through the scientific community. What's the issue? The galaxies captured by JWST don't behave as they should according to the Big Bang Theory. They're too small, too smooth, too old, and there are too many of them. Here's the conundrum. If the universe is expanding like a balloon, then galaxies should appear smaller the farther they are from us. Eventually, they should start looking bigger again, as their light traveled from a point closer to us. It's a peculiar but essential part of the expanding universe theory. But in JWST's images, galaxies appear just as big as the ones near us. It's like expecting distant friends to show up as tiny dots on the horizon, but instead they're standing right beside you. Some of these galaxies, despite being farther away, appear smaller than expected, even those that shine brighter and have more mass than our own Milky Way. JWST's photos reveal galaxies that are much smaller than those seen through Hubble's lens, even though they're more luminous and massive. Even more puzzling is that these galaxies have incredibly high redshifts, meaning they're moving away from us at rapid speeds. If you were to assume the universe is expanding, this would be strange. But in simpler terms, the galaxies captured by JWST seem to act like they're not part of an expanding universe at all. Instead of becoming smaller, they appear as if the redshift is only related to distance. Let's break this down further. These far-off galaxies should be tiny if we follow the logic of an expanding universe. Take, for instance, a galaxy named GHC2. JWST identified it as far brighter than the Milky Way, yet it's only 300 light-years across, compared to our Milky Way's 50,000 light-year span. Its brightness per unit of space would be many times greater than the brightest galaxies near us. This suggests a puzzling disconnect with the expanding universe theory, because these galaxies would be hundreds of times denser than what we see around us today. Now, the expanding universe idea seems to crumble. If these small, dense galaxies didn't expand through mergers over billions of years, then they may not have been small to begin with. It's like expecting a toy car to grow into an SUV after colliding with others, but JWST reveals no signs of such cosmic collisions. There's no damage or distortion from these imagined crashes, and no evidence of galaxies merging to become larger ones. Instead, these galaxies appear smooth and perfect, just like the ones nearby. The absence of damage, the pristine nature of these distant galaxies, is a significant blow to the idea of a cosmic crash theory, which suggested that smaller galaxies merged over time to form the larger ones we see today. It's as if you're observing a busy highway, yet there are no crashes, just speeding cars. So what does this mean? If these distant galaxies weren't small to begin with and we're not seeing the expected cosmic collisions, it leads us to a major conclusion. The theory of the expanding universe, and by extension the Big Bang theory, might not be as accurate as we once believed. These discoveries could rewrite everything we thought we knew about the universe and the fundamental nature of time and space. And the James Webb Space Telescope, which we once thought would confirm our theories, has instead posed new, bewildering questions. The expanding universe concept may not be as solid as we once believed. Recent observations, particularly from the James Webb Space Telescope, have raised troubling questions for proponents of the Big Bang theory. The discovery of small, smooth galaxies that appear to be far older than previously thought challenges the notion that the universe is still expanding. If these galaxies existed before the Big Bang, it would fundamentally undermine our current understanding of how the universe came to be. One crucial factor in this debate is the age of stars. According to the Big Bang theory, everything in the universe began after this event. However, if these galaxies contain stars that are over 1 billion years old, it would mean that the universe's origins are far more complicated than we thought. This raises an important dilemma. If stars and galaxies that are billions of light years away are older than the Big Bang, how do we reconcile these observations with our understanding of the universe's creation? The James Webb Space Telescope, often described as a time machine by experts like Michio Kaku, offers a glimpse into the distant past, capturing infrared images of galaxies billions of light years away. These images are revealing not just the beauty of distant galaxies but also the age of the stars within them. The colors of the stars, blue for young, hot stars and red or yellow for older, cooler stars, help astronomers estimate their age. Based on current theories of the universe's origins, the most distant galaxies should only be around 400 to 500 million years old. However, some galaxies appear to contain stars that are over 1 billion years old, presenting a significant problem for the Big Bang model. Another critical assumption in cosmology is that, as we look farther into space, we're also looking back in time. This implies that the universe should have fewer galaxies the further we look, ultimately leading to a dark age before galaxies existed. Yet, Webb's observations show that galaxies as large as the Milky Way were already forming just a few 100 million years after the Big Bang, far earlier than expected. The number of galaxies at high redshifts, greater than 10, is far higher than anticipated, challenging the idea that the universe was sparsely populated in its early stages. These findings call into question whether galaxies could have formed so quickly, especially within the constraints of the Big Bang model. This suggests that either the theory of the universe's early development is incomplete, or there are factors influencing galaxy formation that we don't yet understand. On a deeper level, these discoveries also challenge our understanding of time itself. Modern physics relies on the concept of time as an integral part of the fabric of reality, deeply embedded in Einstein's theories of relativity. But what if time, as we understand it, doesn't actually exist? Some theoretical physicists have speculated that time might not be a fundamental aspect of reality, but rather an emergent property or even an illusion. If this is the case, the idea of the Big Bang as the beginning of the universe could be entirely flawed. Without time, the concept of a universe starting at a specific moment would be meaningless. This perspective would force us to reconsider not only the origins of the universe but also our fundamental understanding of reality itself. If time doesn't exist as a linear sequence, then the universe may not have a clear beginning or end. Instead, it could exist in a state where past, present, and future coexist, challenging everything we know about the nature of existence. In light of these revelations, the debate between the Big Bang theory and the steady-state theory of the universe, an idea that the universe has no beginning or end, with matter constantly created to fill the gaps left by expansion, has taken on new significance. While the Big Bang model suggests a universe with a distinct origin and a history of continuous expansion, the steady-state theory proposes a universe that has always existed in a state of equilibrium, without a clear starting point. In summary, the James Webb Space Telescope is not just offering us new images of the cosmos, it's also presenting data that could fundamentally alter our understanding of the universe's history. These observations suggest that the traditional Big Bang theory, in its current form, may not be entirely correct. Instead, the universe could be timeless, with no specific beginning or end. This doesn't necessarily mean our entire understanding is wrong, But it does imply that there are far more complex and deeper aspects of the universe at play, elements we have yet to fully comprehend. This is an exciting time for space science and cosmology, as we stand on the brink of potentially groundbreaking discoveries that could reshape our understanding of the cosmos.